Hi everybody. Now we're putting together a quick video on parallel arrays. We know that an array is a single container with multiple compartments. Okay? And we talked about how you access the individual compartments with 0. Like in this case it's LNAME for last name, LNAME 0, LNAME 1, LNAME 2, etc. Okay? Parallel arrays are basically two separate arrays that you declare that have the same number of compartments, or the correct word is elements, the same number of elements, containers for data, and you expect to contain related data between each other. So you expect that the first compartment of LNAME is going to have data that is related to the first compartment of ID number. So in this case, we're going to have a little program that has all the customers' last names in this container, and then have all of the customers' ID number in this container. And as long as we put them in corresponding element numbers, the data will be related. So if we put, say, Johnson in the first compartment here, we're going to want to put Mr. Johnson's ID number in the first compartment here. That way they relate, and from then on you can access these by a single number and get related information. Let's see how we're going to do that. I wrote a quick little for loop that will populate, which means put data inside of both of these arrays. Now you'll just go ahead and assume that I've declared this array as string, which means it's going to contain strings, LNAME, which means last name, or stands for last name, and then there's going to be 7 elements or compartments in this array. And then the same thing with the ID number, except I've called it num because it's going to hold numbers. ID num is the name of the array, and then a 7, the same number of elements. Now in the for loop, we start with for I equals 0 to 6, step 1. Well, in this case, I'm going to go ahead and start with 0 because that's what the computer starts counting with. 0, 1, 2, 3, LNAME 0, LNAME 1, LNAME 2, etc. Same thing with the ID number, 0, 1, 2, 3. So for I equals 0 to 6, step 1, that means increment it 1 by 1 every time it runs. It's going to output the prompt, enter customer's last name. It's then going to input the number from the person typing the name, and it's going to replace the I with whatever I is equal to. So the first time run through, it's going to be equal to 0. So it's going to put the customer's last name in the first compartment of 0. So in here, if I typed in Johnson, the name Johnson is going to be in the last name 0 pocket, or compartment, element. The next line is output, which is another prompt, enter customer's ID number. And again, it's going to input the ID number from whoever types it in and place it in the 0, which is in the place for I on this first time around, into the 0 element, which is the first element in the array. So here I've got Johnson for the last name, and then here I have Johnson's ID number. These two are related, and that is the concept of parallel arrays. Now, once it gets to the last line in the for loop, it's going to go back to the top and say I is now equal to 1. It incremented 0 by 1. And it's going to run through this segment again, except instead of putting replacing I with 0, it's going to replace it with 1 because I is now 1. So it's going to put the next name in LNAME 1. So that one's Smith. Then it's going to put the ID number in the ID number 1 slot, and it'll put his Smith's ID number in this slot. It'll keep repeating this one after another, putting Jones, Jones ID, Humperdinck, Humperdinck's ID, Leslie, Leslie's ID, James, James' ID, and Obama, Obama's ID. So now we have a populated array, and they are parallel because the number of element, the designation of element 0 and 0 has related information, or 3 and 3 has related information, 6 and 6 has related information. Okay? Now this is the one way to do it. There's an alternate way, and that is for I equals 1 to 7. Now, sometimes it just seems to make more sense to count from 1 to 7. But if you do that, you're going to have to compensate for the fact that the computer still starts at 0, even though you're going to count in your mind from 1 to 7. 1, 2, 3, 4, 5, 6, 7. So what I've done here is I say for I equals 1 to 7, step 1, I, the first time through, is going to be 1. The element is equal to I minus 1. 1 minus 1 is 0, so element is now equal to 0. I'm going to prompt for the last name. They're going to put the information in, and then it's going to store that information into LNAME element, which right now is 0. LNAME 0, and it's going to put it in the first compartment. Now, this works out many times in programs where you need to be able to, in your mind, count from 1 to 100 or 1. Rather than try and compensate before you write the loop, it's more clear to say 1 to 7, and then just do one little step in here to compensate for the computer starting at 0. Okay? Well, I hope that makes sense. Again, a parallel array is 2 or more. This can go on and on and on with these arrays. You could have their last name, their ID number, their first name, their zip code, their credit card number, all sorts of things. All right, thanks for watching. Hope it helps.